In today's video, I'm going to try to show in the most logical way how I got to the point of looking at global warming in the way that I do, which is take any day of the year and look at its time series history over time. So I could do that with today, which happens to be August 13th. I could go extract all the August 13th data from every monitoring station around the world and do time series histories at every point on uh, every point of at every monitoring station. I could look at the time series history for August 13th, and then I could see whether or not temperatures have increased or decreased. And I've done that. So basically, I took about 530 million records of data of maximum temperature, minimum temperature on the daily basis, as well as precip. And I've organized it, essentially, just taking each day of the year at each monitoring location and putting it in order so that when I did that over the past few years, I recognized these patterns of heating and cooling were developed. These patterns are so profound that there's no way that they could be just random. There's reasons for them, and what those reasons are is still the mystery. That has to do something with the jet stream, perturbations in the jet stream, and obviously the overall changing composition of the atmosphere. But I want to show what it looks like, what the actual data looks like for any particular day. In this particular day, we're going to pick January 11th. So when we look at the January 11th change in daily maximum temperature from 1960 to 2021, that's potentially 61 years of data, technically 62 years of data with the inclusive nature of time. And when I built this model, all these linear models, which turned out to be 667 million of them, that's a lot of linear models because you've got all the monitoring stations around the world. There's over 38,000 of those that have data across this time frame. And then you have 365 days of data. You start multiplying it out and you get a lot of linear models, 667,000 of them. I said million, but it's 667,000 of them. And when you then take the change in maximum temperature from 1960 to 2021 and you plot it as a map as I'm showing here, as I scroll across these, I could see any individual monitoring station that I want. I could see this one in Kansas, for example, shows the linear model predicts about a 14-degree change, and because it's red, it's heating. And so what's interesting about January 11th is that heating is profound. It's covering the entire country of the U.S. as well as Canada and Alaska. So other days of the year aren't like that. If we go back to January 1st, we have cooling zones that develop, and we have some heating, and each day has its different characteristic. So let's take a look. For example, here's January 9th, 10th, 11th. You could see that they all have different characteristics, but let's switch over to a different view, which is all the data that went behind the production of this map. So by switching over to that Tableau file, what we're going to see is a pretty interesting amount of information. It's pretty massive. There's a lot of information here. So built this dashboard that allows you to pick a country and pick a state, especially if you're in the US, and then you can pick English units or metric units. So right now we're in degrees Fahrenheit and inches of precip. We switch over to metric. That'll switch to degrees C for temperature and centimeters for precip. So we'll stick in English units right now. And this is the month, this is the day of January 11th. This is the state of Nebraska. Now, these monitoring stations, the size of the dots here represent the number of years of data available at those monitoring stations. So for example, this one here, Loop City, has a 112 years of data. I can pick any of these, and we know from the previous map that no matter what I pick here, we're going to see pretty much an upward trend. Now, this is everything selected in the state, and if we look at this trend line in maximum temperature, we could see that it's a rising trend. And this is the minimum temperature. It's pretty flat, maybe slightly up. These are the individual days of precip and the accumulation of precip at every one of these monitoring stations. So let's, because this is the entire state, let's take a look. Let's just sort of randomly pick stations. So here's one, Bridgeport, Nebraska, 117 years of data. And if we look at its temperature record here, we look at the trend, we can see clearly that the trend is upward. And this is across starting in 1900 going through the year 2021. So recognize that the work that I did basically started here in 1960. And so this is the entire history of the data, but from 1960 forward is the data that I used to create the previous map, what I call the global warming map of the U.S. So here's an example station, the whole history of it. In this case, you see the minimum temperature is also rising. We can see the amount of precip. It doesn't rain. Not very much precip at that location on January 11th historically. And for any given location on Earth, you can see what the precip field looks like. We pick another station randomly picked. Not as much of a change, certainly, you know, to look at the specifics, we'd be going from 1960 forward. But over the long term, not as much of a change there. And here's another one that shows more of a change. This is over 107 years of monitoring. So really, this is a dashboard that contains all of the daily data for all the monitoring stations around the world. It's not just the US. So if I were to pick a different state, say California, we could look at that. And what's nice in the US is that by just essentially picking state by state, you don't get a data overload. You can pick any individual station you want to take a look at its trend. This one here actually shows a downward trend over that long time frame of how many ever years that is, 47 years. And this actually stops in 1967. So this would not have been used in linear modeling for the work that I did. And nothing, basically the linear modeling has got to go from 1960 to 2021, pretty much with at least 57 years of data. So this thing is an interrogator that allows you to look at any individual monitoring station around the world. So if we were to switch to a different country, for example, let's go pick, let's pick an all here and go over to, say, for example, I don't know, maybe we'll go look at Germany. There's lots of great information here. Let's go look at Germany. Here's the country of Germany. Lots of monitoring stations. There's the trend in Germany over time. This is going back to 1826. So there are some monitoring stations in here with lots of records of data. So anyway, this dashboard allows you to interrogate any monitoring station from around the world that has data, lots of information. So if you take this dashboard and you download it, you can simply change the day of observation. You can download all the individual days from my website once I have them published, and you can substitute for January 11th, you could substitute any day of the year that you'd be interested in looking at. And so that way you have access to all 526 million records of precip data, precip temperature data from these monitoring stations. So that's kind of the overview of all of this. And I think when you spend enough time in the seat and you start looking at this data, you find some very interesting behaviors in different places around the world. So I think I'll stop at that point. Thank you for listening. Thanks for keeping track of the work that I do.